really long.
We can have. Here, I brought a game. We can play this game.
We can start.
Now here's Okay, so here's just while we're waiting, we can try this. We can try a couple different names. So this is Ancestry.com. They have gathered all this public data mostly, and then they digitize it, connect it. So they have a little thing telling us how we can look up how does your family stack up to the average life expectancy. So as demographers, we especially like the word average before life expectancy. Okay, so we can try some names. Angel Cohen did this, so we can try Cohen. And see. This is pretty. And if you have a UC ID, you can use Ancestry as much as you want. They don't ask you for this. So here's where the Cohens live, and here's some pictures of things. So here's how they. Here's average life expectancy of the general population. Their average life expectancy, and the Cohens used to be really disadvantaged, and they became really advantaged. So there's a widget for this. You can try any name. Should we try Schneider? I don't know.
I was going to say, we could be a great demographer.
We can try one of our. We can try. We can try any name. This was not my entry into this, starting with names and doing this, but it's something I discovered later. Okay.
Try mine.
Bow. Okay. Are the bows long-lived or short-lived?
Change it.
Okay, that's from the same place as the Cohens, except for Louisiana. Oh, the bows are very long-lived.
Interesting. So are we picking up Holocaust and World War II effects with Jewish names? Are they capturing that?
No, this is the data for this is Social Security death records.
Oh, so it's all within the U.S.
And the problem is basically that it's the people dying who have Social Security cards that got into the database, and so they used to be really young people.
Yeah.
And they became really old.
So
This isn't life expectancy.
All right. All right.
Yeah.
All right. I'll introduce you.
Okay.
All right. Great. Okay. Every speaker is now supposed to bring a game, so make a note of that. That'll be good. Okay. So it is a real pleasure to introduce Josh at this week's Demography Brown Bag speaker. As you know, Josh received his PhD here in the Department of Demography as a member of what cohort? I meant to look this up.
I don't even know if it's entering or leaving. I finished in '96.
I can't do it. All right, fine. And then he was promoted from assistant professor to full professor of sociology and public affairs at Princeton University, where he was also an affiliate of the Office of Population Research, the much impoverished and resource poor cousin to the Berkeley Population Center. Josh then took on the directorship at the Max Planck Institute of Demographic Research before joining us here at Berkeley as Chancellor's Professor of Demography in 2013. Josh's research interests include fertility, marriage, social demography, historical demography, population aging, and formal demography. He is famous for his articles, How 4.5 million Irish immigrants became 40 million Irish Americans, Marriage Delayed or Marriage Foregone, which I cite in everything I write, and The End of Lowest Low Fertility. This work has been funded by NIH and Russell Sage, and in recognition of his scholarly contributions, Josh was recently inducted into the American Academy of Arts and Sciences. His current research includes a new interest in big data and naming patterns, particularly what first naming patterns can reveal about fertility intentions and how the choice of first names influences life chances. I also want to say that Josh has been an important teacher and mentor to me at every stage of my still brief career. As a first-year doctoral student at Princeton, Josh literally introduced me to demography. I had very little idea of what it was, even though I was in the graduate program. And he taught me the demographic methods course, that core foundational course. As an advanced graduate student, Josh welcomed me, even though I was a middling student in his demography course, as a visitor at Rostock and gave me really great feedback on the dissertation chapter. And now we're landed at the same place again, and Josh has been a wonderful and welcoming colleague, a cheerleader and a supporter, and I'm delighted to have the chance to introduce him. Thanks, Josh.
I have to start with tears in my eyes. Thank you so much, Danny. That was really nice. So this year, as you know, is we'll have a lot of in-house speakers, and our goal is we have a huge set of immigrants here, 10 new students, and so we're taking advantage of that to present work by Demography faculty, UC faculty, and people who are in the broader area. So I'm going to present today work that I started a couple of months ago on immigration and longevity, the longevity of immigrants. This is a larger project where we have some linked data from the 1940 census and the death records that Ancestry was using. So we have millions and millions of people who've died, and we know a lot about them. And one of the things we know about them is where they're born. And the topic I'm taking on today, originally it was going to be a topic similar to what Danny just described about how parents invest in their children and what outcome that would have for them. And so I was looking at ethnic orientation and how long people lived. But that didn't work at all. And so I stepped back one step and just said, well, how does whether you're an immigrant or not affect how long you're going to live? So that's what I'm going to talk about today. And the finding that was new for me was it's well known that immigrants have lower mortality rates than natives in the United States. But what was new for me is that using this data, we were able to look at the children of immigrants, and so that's changing the way that I'm thinking about this. Okay, so I have a bunch of thanks. So Monica Alexander, who just graduated, developed some very nice, she actually helped with the matching and did the matching data set that I'm going to use. And she also has developed a lot of estimation techniques with this data that I'm not going to use in this paper, but that I should be using. And then I have 3 new collaborators from the first year cohort, Andrea, Casey, and Felipe, who are all helping. This is only going to be for men, what I'm talking about today, and one of the things they're doing is helping us build the matched female data set. And then University of Minnesota, and Chris Muller's here, but Chris said, why aren't we a depository for this great full count census data? So thanks to him and University of Minnesota for making us a repository. That's for the 1940 census and all the covariates and the names that allow us to match. And then we have Carl Mason, who set up our platform, but also is our interface to the legal community, because you have to get permission to use this, and he's been really fantastic. And then Ryan, I don't think is here today, but Ryan and I did a paper on a similar topic using HRS data, which was an inspiration for this study. Okay, so the bottom line here is the same as in Lake Wobegon. It's the place where all the women are strong, all the men are good looking, and all the children are above average. And so what happens here is all of the immigrants, practically, there's some exceptions, are above average, and all the children are above average. And there's something going on. So how could this be? That's the mystery we're looking at. I don't know, in this era, are we allowed to use this quote? I'll leave that as kind of a question, a Twitter-like question. And notice I've removed this source. Okay, so our background here is the Hispanic Paradox, which is sometimes the Hispanic Health Paradox or the Hispanic Mortality Paradox. And I don't really know the history of this, but it's fairly recent. I think the first papers are late 70s or something like this. But I wouldn't be surprised if there were similar things discovered much, much earlier. So the basic argument in social epidemiology or gradients of health is that the better off you are, the longer you live. And the surprising finding here is that Hispanics and both native-born and foreign-born, despite being disadvantaged along most measurable dimensions, live longer than natives. Okay, so This has launched 1,000 papers, and the motivation here, the framing for all of this, is not to figure out how can we provide better services to Hispanics. It's rather, what's the secret to Hispanic health so we can apply it to everybody else. So the idea is that if we can understand what the special thing that Hispanics had, then it would allow us to better understand what's really driving health, and then also to confront group disparities in general. So that's the big motivation. I think my conclusion will be that it's probably not that. We don't have that much hope for using this paradox to learn that much. But we can still try to figure out what's driving the paradox. Okay, so I'll begin with my questions and my conclusions. The first question that we can answer with this big data set is we have so many people, we have 7 million people, so we can look at people from all over the world. And so we can ask, does this apply just to people from Mexico, or does it apply to people from all over the world? And the answer is going to be, mostly it applies to people from all over the world. There are a couple of exceptions. Do we have a guess at the exceptions? Where do people come from that I've shown this to so many people? They've probably seen the slides. Any guesses? Europe. Okay, yes. Okay, most of these countries, I'm talking, the context here is immigrants who came in around 1900, 1920. So most of them are European, but I have non-Europeans here. Where in Europe? We'll see. Okay. Does the immigrant advantage persist to the second and third generation descendants? So we're able to do this because we have census data, and in the census, people are asked, where are your parents born? So we can immediately identify second generation immigrants, of people born in the US, whose parents are born abroad. And then using last names, we can get the sense of, we know you're from a place given your last name, but both your parents were born in the US, so you're a 3+ generation immigrant. So kind of like the Hispanic surname thing, but we can apply it to all groups. And the answer is mostly, this is an advantage that persists. And then, so I'm going to show this probably in the first couple of minutes, and then the last part will be what are the causes. And the cause that I'm going to argue for, not because I have a lot of proof of it, but just because I think it's probably right, and the evidence is pointing in that direction, and this is still an early project, is that immigrant selection is driving this, but it's not immigrant selection on health, it's immigrant selection on something else that is able to be passed down multiple generations. So, what are the existing explanations for the immigrant mortality paradox? So, the most popular explanation is that this is health selection. People coming in people who are in poor health don't arrive, and people who are in poor health don't stay. So there's also returning people who are sick who return home. And one could put kind of a subcategory of this would be kind of data artifacts that we don't measure, we don't see the deaths, or we see too many in the denominator because we don't see people return home. So, and if this is the answer, then it's all rather uninteresting. I mean, it's interesting from the point of view of who migrates, but it's not interesting in terms of what's the secret to health. The secret to health is being select. Okay, but most of so there's a big part of the literature on this. There's another big part of the literature for the more people hoping to learn something from all this. One is that people from other countries have different behaviors, and these different behaviors are themselves good for you. Walking around, eating good food, not smoking, not being too stressed out. I mean, I don't know. These things may or may not apply to immigrants, but they're kind of tossed out as ways that it might be good to be from another country. The other version of this is, being American is bad for your health, and assimilating is bad for your health, and there's certainly a whole literature on this. And then, relatedly, but it's not related to any particular ethnic group, but rather just being a new immigrant is maybe you live in a differently structured community and you have different sources of social support. It could be your extended family, it could be your co-ethnic neighbors. And so the idea is that these things are good for your health. And again, we don't know what drives health. We don't know what drives longevity. So these are all rather mysterious things. Probably smoking, drives health. But everything else is fairly speculative. And this is just another version of assimilation is bad for your health, because when you assimilate, you stop having your protective family and your protective neighborhood and all that. So are there other things? There probably are. There are people in this room who are much more expert on this, so please afterwards tell me what the other things are that we should be looking at. So this is kind of how I read the literature. Okay, so we've already done this. This was looking at the Social Security death records by last name. And I think I was going to try some names. We already did that. And what we saw was that there are these records that have people's names on them, and they tell you how old people were in each year when they died. And Ancestry, because they didn't have a demographer, didn't really do this right. And they said, oh, the age of people dying in that year is the period life expectancy, which is not right. It's just the average age of death in the population, which is affected by age structure and who's your family and all these type of things. And so they kind of got it wrong. They said life expectancy was 25 in 1950. But maybe they got the relative order of the different groups. Could be right. Should we try one of this? We'll come back to this if we need to. I'm a little bit worried about time. Okay, so what are we doing? We're going to take the same data that Ancestry was using. I didn't know they were using at the time. And that's the Social Security death master file. So this is people who are registered at people who have records at Social Security. Social Security keeps track of everybody, and when you die, they try to keep track of that. And there was a Freedom of Information Act lawsuit done several decades ago that said this information should be public. And so there's this file consisting of 80 million deaths with people's birth date, death date, and their names, and their Social Security numbers. And then various things happened, and Congress stopped making this so publicly available. So this is not an eternal resource, eternal public resource. This is kind of, thanks to the glories of our legal system, it's kind of one big version is available, and it has these 80 million deaths. So we match this. I should say the deaths are very complete from about 1975 to about 2005. And these are deaths of older people. There are young people in the database, but we're gonna not work with those. So in 1940, we have about 130 million people, and we have all the covariates of the very rich 1940 census, which includes education, income, place of birth, your street address, how much, your occupation. I mean, it's a very, very rich census. And so what we're able to do is match people's characteristics to the death master file. Now we do this just with names, and we do this try to do it in a way that we don't get a lot of false matches. And so our first version has about 7 million matched people. They're all men. They're all born 1900 to 1920, and they're all dying in 1975 to 2005.
Josh, how many would you expect to have if you had been able to?
This is about, I think, a 50% match rate of what we would, if we could match perfectly, what we would get. Yeah, maybe 40%. And then we have some new data from National Archives that is going to allow us to get women's maiden names and then match the women. Okay? So what does this look like? It looks like, here's our 1940 census, here's our Social Security deaths, and here's our birth cohort. So we see people when they say age 20 to 40, and then they die age 65 plus, and you kind of get a sense of the challenge here now of estimating mortality, seeing only this segment of deaths, of interpreting our covariates given that they're back here. Okay? And also for immigrants, these are immigrants who had to be around in 1940. This is not a good sample of immigrants dying in this period. Mm-hmm. The people we're going to look at are all going to be around in 1940. So some of our challenges, we're doing nominal record linkage. So for example, we don't match Al Gore and Albert Gore. Okay. We have to match mortality. We have to estimate mortality. We don't have denominators. Not matching doesn't mean you're still alive. There's lots of reasons for not matching you. So we can't kind of do the classical follow-up and see who's died and who's survived. Instead, we've just got a distribution of deaths. And Monica, her dissertation chapter is called Deaths Without Denominators. Okay? And then we have this window of observation. We observe the characteristics in 1940. So something like education is probably a pretty good measure for most of these people, but income is rather strange. It's a very temporary measure. And also place of residence is going to be their place of residence in 1940, not in the many years afterwards. Okay, so I think I'm going to skip the demography here. Okay, maybe I can do this quickly. Okay. So how do we estimate? We have a distribution of deaths in this little slice, and we don't know how many people were exposed. What can we do? Well, typically, if we had a cohort that ended up here, that we saw up here, we could do reverse survival and get the exposure by just adding up the people who died in reverse order. Okay, so but that won't work here because we don't know how many people were left out. So that's the first thing. What's not going to work is the usual approach of extinct generations because most of the cohorts aren't extinct. Okay, so what I'll use here is a kind of an adequate approach. So we can just regress on age of death. So linear regression, the outcome is dying at age 76, 75, 79, and the parameters are all very interpretable. That's nice. And if you kind of put in fixed effects for each birth cohort, you're going to get things kind of relatively right. So this is a little bit like the ancestry picture I showed you earlier, where you would ignore the y-axis, but you just look at the numbers on the y-axis. You just look at the relative position of groups. Maybe the relative position is going to be about right if you control for birth cohort. The problem here is that the differences in means in this truncated span of ages is going to be between two groups is going to understate the difference if you include all the tails. I'll show you a picture for that in a second. So it's a kind of a conservative way. It's super easy. You can try out lots of things because you're just doing linear regression. And that's what I'm going to present in this paper, in the presentation today. And then the best thing to do is to explicitly account for the truncation and estimate some kind of model life table or some other approach. And that's what Monica did in her dissertation, and that's what I'll be doing before PAA if I present this at PAA. Okay, so here's my point just about all of the effects you're going to see are going to be relatively small, and this is just my caveat in that the true effects are bigger than what I'm going to show you. Okay, so let's say we have the reds and the blues, and the mean of the reds are here, and the mean of the blues are here. Well, if we cut off the tails, the difference in means is going to be much smaller. Okay, so how do you understand this? Let's say we're doing average height of men and women, and we get rid of all the people over 6 feet and all the people under 5'8". Well, all of a sudden, the difference between men and women isn't going to be very big because there's a lot of women below 5'8", and there's a lot of men above 6 feet. Okay. So, this is all. The first thing we're going to do is we're just going to estimate what is life expectancy at age 65 for each immigrant group. Okay, and we'll define our first generation to be. It's always people born in 1900 to 1920. They're observed in the 1940 census, and they're born outside the United States. And even that's not a non-trivial question, because the definition of the United States is changing over the century. But more or less, these are people born in Europe, Asia, and Mexico. Then we have the second generation, which is going to be people who are native born. The important caveat here is these are people who are born at the same time. These are actually not the literal children of the first generation. So these are not the literal children, but they are the next generation. These are the children of people who were born in the 1800s. Okay. And then we'll have the natives, also born at the same time. They'll have native parents. Okay. I forgot to part of the advantage of being an immigrant might have been that you were non-black by and large. Okay? So to make things comparable, I've dropped the blacks from my sample, and I'm comparing to white natives. Other questions about this? Definition?
We're going to Caribbean immigrants?
They could be in what I'm looking at, but I'm only going to look at, I think, the largest 40 sources, and so I don't think they're going to be in my pictures. But one could, I mean, the samples are small, but they're much bigger in our sample than any place else, so you could conceivably study them. And interestingly, black and white mortality are not that different at older ages for these cohorts. They're not as big as the difference between immigrants and natives, for example. So it actually didn't make that much of a difference to exclude them. Yes?
So it seems by this, most of California would be second-generation immigrants having arrived from the east coast of the United States.
So we're defining our immigration by international immigration, but these process selection things the theory should apply to internal migrants, and we have state of birth for everybody, so one could repeat the analysis or try to get some benchmark it or do something creative using internal migration as well. And you can also look at people who landed in one place and moved somewhere else, two mover immigrants. There's also where did you live 5 years ago questions, things like that. So you can look at multiple moves. Okay, so here's the kind of bottom line. Is the text big enough that we can read it? Okay, so this is regression analysis kind of converted to the output where we can read it. This is kind of E65. So the native white population, native-borns whose parents are native-born, about 13.7 or something, and all of the immigrant groups, more or less, live half a year, 1 year, 2 years longer. So these are big proportional differences, big differences in hazards. I don't know. I haven't converted it to what proportional change in mortality rates, but it's going to be a really big change in mortality rates, like 50% or something. And then there are some groups that show somewhat worse outcomes. Those are the Irish. That was the answer to my earlier question. The Scottish. That's another allowable answer. And the French Canadians, who are indistinguishable from the natives, but still the mean is right here. And these bars are only one standard error. So if we're doing two standard errors, it'd be twice as wide. Okay. So I've added a little color to make this interpretable. These are not official regions. These are just Josh's categories. So I put Japan, Philippines, and China together. So those are super advantaged groups in terms of mortality. Black is kind of the middle of Europe kind of thing, England. So they're kind of spread out. Scandinavia, we have some very advantaged groups. I should say that the ordering here is the order of the estimates. And the estimates are subject to error, so we shouldn't read too much into the fact that one group is higher and one is lower. Rather, these people are very live much longer. These people live somewhat longer, and these people live only a little bit longer. Not the actual order we shouldn't make too much of. Yes.
Do you have the rates of matching for the different groups? Are they about the same within the two databases?
Rates of matching. I haven't looked at that, but what are you thinking? So our assumption here is that whether you match or not to first order is independent of everything else. So we might have different matching rates, but that shouldn't affect the analysis too much. But we can also check and see, does your matching depend more on income in one group than another, and that sort of thing. These models, these results have no covariates, but I put in lots of covariates. It doesn't really change anything. I'll show you a little bit later of that. But is that your concern, just that my Italians in my sample are going to be represent a different fraction of the Italian immigrants, a different kind of representation of Italian immigrants than, say, the English? Because the matching might be different?
Matching is partially based on names, and names get more corrupted based on the language. So like the English wouldn't have as many, they would have more matches than some other.
But if the matching rates are different, let's say I found the matching rates are really different, because it could be, what would you think the problem would be, the analytical problem, if the matching rates are different?
That the people who matched are more assimilated.
That your probability of match has to do with assimilation. Okay. So I don't know the answer to the question about what the matching rates are, but there is the issue that people who change their names between 1940 and their Social Security application, which could be many years later, are not going to be in the sample. So that's a really good point. Yeah. We have a file with all the name changes. Once you've applied for a Social Security card, then you change your name. That's how we're going to do the women. So we may be able to do a little bit of work on that. Yeah. And then we're going to look later at just exclusively ethnic names. So we'll kind of narrow it to people who don't change their names, and that won't really change the analysis. Okay. So Greece and Turkey are interesting. Super advantaged groups. Syria, very advantaged. Finland, terrible. Especially if your benchmark is Scandinavia. Okay. So here's the pattern. What's driving this? Well, pardon? Alcohol. Okay, so we have some the Finns, the French. I don't know. Irish. Are there any big drinkers up here? I don't know.
What is this?
Seminar on ethnic stereotypes. Russia is a code word for Jewish here, by the way, for this time period. Almost everybody coming from Russia is going to at least have a Jewish, what sounds to me like a Jewish name. Yeah, so alcohol is probably some part of this. I think also, for the Asians and the Greeks and the Turks, they're coming a long way. This is probably, they've done a long voyage, probably more selective than some of these other groups, the English, the Irish. Just a short, cheap steamship ride. Carl was telling me how cheap it was to go by boat from those countries. So selection is part of the story. How about behavior? I don't know. The Danes are not famous for their really fine vegan food, right? And they don't have a lot of olive oil. Okay, so we don't see a lot of patterns. And to me, that's, we could just kind of stop here and say, look, immigrants are advantaged in general. It's all driven by selection. We'd have to do some more work to see that the Irish and the Scottish were somehow less select. It probably has nothing to do with anything. It's just being an immigrant is good for your health. So we can skip most of this, because I said all of this, I think. Migrant selection. So we can look at children. The children are not select. Okay? The first thing we're going to make is children are not select. And if that were true, we would be able to defeat selection by finding effects in the second generation. However, our footnote to the children are not select is, okay, they're not select in the sense that there's no migration selection on the children. They're just born there. They didn't choose where they were born. But their parents were selected for, and so anything that their parents can transmit to them makes the children select. But what the children are transmitting is not health status directly. Somebody with TB may not have come into the United States, but the parents are not transmitting that, having or not having TB. Mm-hmm. But they are transmitting all kinds of other things.
Yeah. Couldn't they be transmitting health fairly directly? Aren't there these in utero effects? So if you're a healthy potential migrant versus a bunch of unhealthy people, and you have children, you do have healthier, perhaps, children, not just in a social way, but in a biological way, who then migrate with you, or after you, or precede you.
So I'm not going to present this, but my basic argument against transmission of health directly is that when we look at objective measures of health, like height, the immigrants are terrible. So the immigrants in general are, on what we can see, not healthy compared to the natives. But that's just one example, and I think that it would certainly be worth looking at. I think the other thing one could do is try to quantify how much is transmitted, whether it's genetic or some in utero type of things, and try to see, would that mean, how much regression to the mean would you expect after each generation from that, and does it correspond to what we're going to see? Okay, so here, is this visible? Okay. So I haven't quite figured out the graphical way to present this. So what we have here are the same points in black and the second generation in red. Now, of course, presenting uncertainty is the wrong thing, right? if it's really uncertain, it gets lots of ink on this chart. So all of our eyes go to Cuba and the Philippines. But those are the least informative points, right? We really want to be looking at these tiny standard errors of Germany and Russia and England and I can't quite see which are which. But so the story here that I would argue the big story here is that the red points are basically in the same order as the black points. That's like first order observation. The second observation is there tend to be a little bit inside of the black points. There is some regression to the national average, and we shouldn't pay too much attention to the noisy points. Okay. So we can view just the points in general. So here's the same information, just looking at a scatter plot of first and second generation. I didn't label everything, but we see Ireland and Russia, there's no regression to the mean. This is the 45-degree line. They just have the same longevity, whether they're first or second generation. And a lot of the non-correlation is driven by those countries that there's a huge measurement error on because we're just not very certain about it. And in general, we just see everything line up. The correlation here is 0.6 with these points and 0.85 or something without those points. Okay. So the story is that the immigrant advantage is also the immigrant's children's advantage. That's the story. So how does that fit with selection? It does not apply to the selection on the health cells of the immigrants. It only applies to things that the parents can transmit to their children. Okay, what are they transmitting? Genes, assets, values, non-smokingness,
diet.
Yeah.
Where's the native point on that?
The native point would be at, I don't know, something like here. But it may even be off the diagonal. I'm not sure. No, there's only one. There's only one of them.
Yeah.
So yeah, it's going to be. Yeah. What else? So they're transmitting something, and I'm not going to tell you what is being transmitted because I don't know the answer. But I can investigate some of the things that I thought were being transmitted, and I can show you they're not being transmitted. Okay? So the first thing is we can look at SES. So we can control for lots of things, but it turns out that the only things that make a big difference are education and urban-rural status, and maybe state of residence. And here we see the immigrant paradox at work. If we control for these people's disadvantaged position, then it makes a bigger difference. They're actually disadvantaged. Because the black dots, which are the with the controls, are farther away from natives than the white dots. And in fact, the Irish is interesting because the Irish are worse off in terms of education, and so once we control for education, they're actually more like natives. Okay. So this is not that that's surprising because we have the Mexican effect. Now, this is the country that's really been looked at a lot, which is if we control for characteristics, it becomes even more surprising. We're even farther away from natives. Okay, and when we look at the second generation, I don't know, kind of not much happens. They tend to move, not much, it doesn't make much difference. Okay, maybe Russia might be an interesting example. So the Russian difference for the second generation is slightly smaller because the Russian Jews, their children tend to be more educated, more like natives in terms of education than the immigrants themselves. So they move slightly inwards. So observable characteristics, observable census characteristics don't do much to explain anything. It's the bottom line here. And if they do explain anything, they just make the paradox stronger. So what can we look at? So somebody said resources, or we also have house value. I think we can look at house value being passed down. So let's think about culture here. What is it somehow being from Italy that's being passed down? Italian culture, Filipino culture, something like that. And because we have the full census, we can actually do some new things here. So one thing we can do is what I was originally going to do, which was to see if assimilation by changing your name to a more American name or being given a more American first name makes you less healthy. If it makes you less healthy, then assimilation is bad for you. And I haven't done this yet, but we can also look at how people name their children as a measure of their own cultural orientation. Okay? So we can look at that. That's one measure of assimilation. Another measure of both assimilation and social resources is who are your neighbors? Do you live by yourself? I can't do this. It sounds anachronistic because I'm not in 1940. In the suburbs? I don't know if the suburbs in 1940. But do you live by yourself or do you live in an ethnic neighborhood? And then something that I've only done a tiny bit of, which I think is pretty neat, so we can address the cooking hypothesis, the cooking and drinking hypothesis, by assuming that moms are responsible for your eating and dads are responsible for your drinking, and then we can do like the Irish-Italian mixed couples. And if your mom is Italian, then that's good for you, and if your mom is in diet, see who dominates, and that's what. But it's this complicated problem, and that's to be done. Okay. So let's look at the results from these two. Okay. So the names, we score them on how ethnic they are, but it turns out it doesn't predict anything. We can kind of skip this, but just so you get a flavor for what it looks like. These are Italians. Here's the first generation. Here are the Anthonys, the Angelos, the Michaels, very ethnic, and I can't even read it. This one is Charles. I can't read the other ones. Yeah, the size is kind of proportional to how many. It's like the square root of the count or something like that. So I can't. George. These are like the Beatles. George. Paul. Is Paul down here? Yeah. Okay. So there's no effect. It's not statistically significant, et cetera. But if there is any effect, it's that being. It's slightly positive here. Yep. The direction is, but it turns out it's just noise. When we do the analysis, ask if it's noise or not. It is just noise. And the second generation, kind of neat. You see all the names moving over. People are taking on American names, and now the relationship's totally flat. So if it's about preserving your ethnic identity and maybe the things that go with that, maybe, then the story does not seem to be that. And I've done this for all the groups, and it doesn't. I think there's two exceptions. Norwegian is good for you, and Irish is bad for you. But I did like 20 groups, so we should. Okay, so let's do the neighbors thing. So this data set's big, 130 million records. It's not yet coded in terms of the census tracts and things. So I did this for states, and I thought that's kind of inadequate. And then I realized there's a variable in the records, the microfilm reel and the page number. And so I'm using the page number as a place. Okay? And so we're going to use the census page as our place. If you're on the same census page as someone, you're their neighbor. Because how was the census done? It was a person walked with this. Was it a book or was it a page? I don't know how they manage these big things. I imagine they had this book with these pages in maybe a folder or some enormous clipboard. And they're walking from one place to the next. And then we see if there's co-ethnics on the same census page that aren't part of the household. So here's what it looks like. I chose this page as something that's really easy to read because it's block print. But this is Albert Einstein is on here. That's why I chose it. Where is Albert Einstein? He's there with his daughter. Here he is, Albert Einstein, right here. Head. Physics professor, it says out here. And it tells us how much money he made. He made $5,000 a year.
What's the inflation adjustment?
Well, I tried that too. It's only like $90,000.
Higher increasing cost of higher education.
We're overpaid. On this page, there happens to be two people from Scotland from different households. There's no other Germans. Okay. So if the person I was looking at was Scottish, he would get a 1 for having a co-ethnic. And Albert Einstein would get 0 because he has no co-ethnics, except in his own household. Okay. So already this is interesting. I think one could write a paper about this. Maybe papers have been written about this. But we basically have two groups Well, first of all, it's super common for everybody to have a co-ethnic on their same census page. It's only about 10 or 15 households. So even the Norwegians and the Irish and the Germans, who are all in 1900 to 1920, most of them are most of the immigration wave is already behind us. Half of the people have a co-ethnic on their page, and the Norwegians 40%. And then the Mexicans, the Irish, and the Russians, it's like 60 or 70%. Okay? And strangely, second generation doesn't really matter. It's pretty much the same thing, except for the. This is kind of correlated with how recent the immigration wave was. But people lived in very ethnic neighborhoods. In fact, I read something the other day, which was the American assimilation happened in World War II, where people grew up in ethnic neighborhoods and then were forced to bunk with. It's kind of like the Harvard diversity story, right? Except everybody had to do it. Everybody was drafted in World War II, and they were bunking with people from all different neighborhoods, and that was the first time it ever happened. And then, of course, we have the story of white-black integration later, but this was already ethnic integration. You see how segregated people really lived before World War II.
This includes rural places? So the Norwegians in Nebraska, the page might be a huge...
Lake Wobegon, maybe like half the page, and then the next village over maybe, yeah. Yes. Okay. So, does this matter? Okay. Ethnic neighborhoods are not protected. There's no positive effects of having co-ethnic on the same page. So a positive effect would be over here. This would be living a year longer. And all the effects are indistinguishable from zero, every place. Okay, so first generation doesn't matter. It's kind of all over the place. Second generation doesn't matter. Third generation, this was first generation with controls, because it may be that living in an ethnic neighborhood is good for you, but when you get more education and more money and things, that you move out, and so it doesn't look like it's good for you. So we can control for those things. That doesn't make any difference, really. And the same second generation of controls. So the basic story here is that everything crosses zero. There are no significant effects. We have thousands and thousands and thousands of people. So absence of evidence is not evidence of absence, but the bigger the sample, the more convincing it becomes that living next to your landsmen, it's all men in this case, so living next to your landsmen doesn't help your health. And we can certainly control for more. Questions here? So we have negative finding and negative finding. Let's do one more positive finding. Let's do the third generation. Some countries have very distinctive names, and where only immigrants from that country have that name. Okay, so an example would be Tanaka. I don't think there are going to be any Tanakas that don't have some origin in Japan. Now, they may have come here via Cuba or Mexico or Brazil so Olsen, I don't know much about Scandinavian naming practices, but apparently Olsen is only Norwegian.
No, Danish.
With an E?
Norwegian.
With an E?
Yeah.
Okay, so I may be wrong. I may be mixing. There may be some false attribution here with the Olsen. O'Shaughnessy, that we know where the O'Shaughnessy's are from. The Muller, however you want to say it, is going to be German. The Woods are going to be English. And so what I do is I simply look at names that are popular from a country and then ask, are they exclusive? Okay? So I have a few dozen names from each country, and so I can I have enough people from that country. And then the reference group here is going to be English 3+. So these are people with English names who are white, who have names like Woods or... It's funny, it's hard to think of these names, but then when you see them, you're like, oh, of course. So I should send you guys the names. Especially the English names are hard for us to think of, but they're very, very exclusive English names that are not Irish, that are not Scottish. Okay, so what do we find here? So it's maybe a little hard to read. Let's move it up. Okay, so we're going to have let's take the Russians. So these are primarily Jews, people with names like Goldstein. And I'm comparing Goldstein's first generation, Goldstein second generation, Goldstein third generation. So all of the points are using the same definition of where you're from. So maybe Russia should be in quotes, and Norway should be in quotes, and Mexico should be. Distinctively Russian name, distinctively Norwegian name, distinctively Mexican name, doesn't mean you're actually from those places. Okay. So the Russians have an advantage, their first generation. They lose a tiny bit, but you see there's error here. They lose a tiny bit of advantage the second generation. Okay. And then they seem to regain a bunch of advantage the third generation. Okay, our parsimonious description of this is that it's all the same. And then if we control for something like education, the gap, the advantage becomes less so, but it's not that they're suddenly there's a huge increase in observables of the third generation. That's, all these points are the same.
Again, these are third generations that were born in 1900.
1900, 1920. Yeah, that's why the standard errors are big, because, and these are Russian quotes. These are not Tolstoy's, non-Jews from an earlier cohort of migrations compared to the Norwegians, same thing. Interestingly, it's the same pattern, this kind of U-shaped pattern, but standard errors are big, so we shouldn't pay too much attention. Italians, it does look like you lose the Italian magic a little bit. Now, is this just chance? Again, these are not so distinguishable, but it seems like you have this pattern consistently going this way. And the Irish, it seems like you lose the luck, the unluck of the Irish as you get to the higher generations. And then Germans, again, with noise, but basically the same thing. So the story, the point I want to take from this is that the story for the first generation is indistinguishable from the story for the third generation. If I showed you, if I showed you one set of these, the black, the red, the blue, the light blue, you wouldn't be able to tell me which generation it was. Not like one or the right. Okay, so we're ready to wrap up here. What's being transmitted? Somatic health, I don't think so. SES, well, yes, SES is being transmitted, but it wasn't an advantage to begin with. It's a disadvantage. Culture of the country of origin. So the specific culture doesn't seem to help much. Becoming American, as far as names and neighborhood, don't seem to hurt you in any way. What's left? Well, it's likely to be, I would think, something about the characteristics the immigrants bring with us, not maybe the mentality, the values, it could be a whole host of things that themselves are transmitted to immigrants and which the immigrants' children and the immigrants' children transmit to their children. Okay? So, Selection Beyond the Soma, good title, but it's not entirely new. When I was reading about this, I found this nice discussion by Poloni and Eubank. Selection through migration goes beyond the fact that migration rates among those with obviously impaired health status are lower than among the rest of the population. Individuals who migrate may be more educated. Well, that's true today, right today in 2018, after recent trends. But it certainly wasn't true then. Okay? Less risk averse, so that was probably true for the migrants of this generation. More aggressive and entrepreneurial, I don't know. Is aggression good for your health? I don't know. Entrepreneurial, maybe, I don't know. More resilient, well, that's probably good for your health. Low discount rates for the future. This struck me, this kind of rang a bell, because what are you doing when you want to live longer in old age? Well, you're doing some things in the present. If I have a low discount rate, I'm going to behave well now because I want to live a long time in the future, because I value that. So this kind of low discount rates and it's exactly the kind of thing we would think that immigrants would carry with them. Now, is it in the genes, as I think Ken and others have been involved in research about? It could be a little bit in the genes, but probably you don't need to resort to genes for this. This is the kind of thing that you can instill in your children. Right? Care about the future. We certainly try to instill it in your children. Better prepared to face stressful situations. So this is the kind of thing that's probably being transmitted. Anybody who has ideas of how to demonstrate this, I would appreciate. Okay. So I should say my personal bias is towards some kind of individualistic selection-based explanation, because this idea that one culture had good characteristics and that when you lose them, that doesn't rest well with me. Selection is much more palatable for me. You can apply it to any culture. It seems like I'm just revealing my own bias here. Now, this is very individualistic, and so Jenna was urging us to go beyond adding up people, but that's really what I'm doing here. So I think a lot of our better and more sophisticated explanations will take those individuals with this selection and add something to it, how they're interacting, and what the population composition is actually doing. And then, of course, there could be both. There could be characteristics that people from a specific country bring that are shared with the people they left behind, and those are helpful. And it could also be that they themselves are select. So it's probably some both. And the two pieces of evidence on names and neighbors I don't expect to be overpowering. That's just the evidence I have to this point. Okay. So, if I'm right, this is kind of bad news. We're not going to learn any kind of cultural secrets to longevity. Only we eat more olive oil, or live closer to our parents, or whatever. The good news is that we can still study the immigrants, even if they're select. And there are, this HRS, which Ryan and I did the paper with, and which I think probably is that what you're working with too, with the genetic analysis? So you can study discount rates, and you can study health behavior, and you almost have an immigrant, enough people to study, almost. But of course, the lessons of instilling your children with low discount rates is a very different lesson than let's eat more olive oil and walk to work. I mean, it's a much tougher thing. So it's hard to transfer to the rest of us. So that's all I have to say. So thank you. I'll start in the back.
I'm just curious if you could expound on what sort of family specific behaviors you're thinking that would be transmitted on to kids, and subsequently what would that mean for their health. I'm just thinking in terms of acculturation, right? Like, I would presume that as people, as we get into their generation or get more educated or what have you, like people's eating behaviors change, their cultural behaviors change as well. And so I'm curious if those behaviors that you mentioned would hold in successive generations.
Discovery hold up.
Sorry, I didn't understand the last sentence.
If those eating I was wondering if you could talk about what specific behaviors you're thinking of that would transmit and stay in each successive generation, because I'm thinking in terms of acculturation, as you move up, into the third generation, people's behaviors change, right? Their eating behaviors change.
So I guess the strong version of what I'm saying is that it's not eating behaviors. You can change your diet, you can change your name, you can change your neighborhood. All of these kind of simple to describe things you can change, and they're not going to affect your health. What really matters is with the eating, how much you eat, whether you're taking care of yourself. Mm-hmm. It's that kind of thing. Take care of yourself now because you're going to need it in the future. That's the kind of thing that is being transmitted, I'm guessing, and that is kind of doesn't really relate to assimilation at all. You can have that and be assimilated, you can have that not be assimilated, and maybe it could be correlated with assimilation, but not in a causal way. It's not the change in diet or the change in neighborhood or the change in personal identity that's causing it. It's rather this other thing that tells you, do the things I need to do in order to take care of myself for a long time. That's the argument I'm making. I don't know if it's right, but
I think you contradict yourself though, because the education is taking care of yourself in the future.
Yeah.
You're educating, you wait more. You have that. You're waiting longer for future payoffs.
Yeah.
But then you find the reverse with the education.
Well, I'm thinking, I haven't thought about this a lot, but I'm thinking, in what I'm presenting here, I'm thinking education is some kind of SES advancement. And so part of what's happening from generation to generation is there's some change in SES advancement, and so that's what I'm trying to control for. Now, I think you're right in the sense that we would expect and part of what I'm talking about is education in the broad meaning of the word, not just formal schooling, but what parents are doing with their children. And so my story is one about what parents are doing with their children, and we would expect it to be related to education. I think at this time period, it's going to be very true for some groups and not so true for other groups. I mean, you see huge increases in educational attainment for some groups, and for others, not so much. So it's a good point. Carl?
Are your second generation, are those guys defined by both parents being immigrants, or just one?
In this case, it's both. I'm looking at it.
That's because I noticed that the three groups way at the top are very male migrations. They're Japanese, Chinese, and Filipino. So for the second generation, not the first generation, the second generation, you may have a lot of selectivity in the marriage market.
Yeah. So this is one thing one can look at for everyone who's, I should say only 1 in 20 people are asked the question about where their parents were born, but every person who's asked the question is asked where is their mother born and their father.
So I'm trying to wrap my mind around the fact that these generations are not literal generations.
Right.
And combine that with what we know about the history of migrations of these groups, which involve both great, I mean, when we talk about China or Russia, even if you're talking about Jewish Russia, you're talking about huge expanses of territory. And we know that the nature of the migration becomes differentially selective at different stages. So for example, early Italian migration was also heavily male, and that was true later. I mean, you go through most of these large groups, and I think you could make a case that the family quality, family quality of those who came in the 1880s, substantially different than the family quality of those who came just before the doors shut in the 1910s.
Yes. So I think this is a great point, and one can so I think I was trying to think of how can we distinguish between degrees of selectivity from a single origin. And I think the common argument is that the pioneers are the most select, and the people who come the last are the least select. So in fact, you see a little of this. Long immigration streams that have been going for 50, 100 years are not advantaged. New immigrant streams, Switzerland will leave aside, but are, and these tend to be Mexico.
The Japanese immigration and Chinese immigration are stopped early on.
So who are these people?
So the ones who actually are experienced later on are considerably different. I don't know how they got in the country. But,
yeah. So I mean, you're talking first and second generation.
Well, I mean, just saying that's another example. You get the Asian Exclusion Act in whatever it is, 1880 something or another, 1890s, treats the Japanese so much. But the point really being that yes, there's and I'll stop.
Yeah.
Yes, there's a general principle across all these groups who think the pioneers are have more of the secret sauce than the others do. But there's a lot of other stuff going on, including wars, economic depressions, which account for a lot of the migration from Russia is particular periods of economic depression. It just makes the mix of family types. Some have the secret sauce and some don't.
Yeah.
In those countries. And yet your answer to me could be, but yet look how neatly they line up anyway. But anyway.
Well, I think what you're saying is that there's probably, the way I would interpret it in kind of a constructive way would be that if we could somehow measure selectivity and maybe the history of immigration from the place and kind of where you are and then that might help us explain this, and I think it's very worth doing. So the HRS is another source for this. Small samples, but really big measurement about what the special sauce might be. And so it may be that also helps you. And are there national experiments? I'd love to know. Is there any Mario boat lift in 1890 or 1905 where there was no difference between the people who stayed and the people who well, that's a bad example, but a natural experiment that would not have the same force of selection. And there are a bunch of economic historians trying to work on these things, and I don't think there's yet a metric for how select the migration is. A lot of it's on observables, and observables like education are not very helpful in most of these places. Yes?
I'm thinking about, you have the family culture, because we're all talking, I guess, we know what we need to do to keep healthy, and mother knows, or father, whichever culture it is. But some of these cultures get into a point where the reverse, no one wants to do what their parents are telling them what to do, and that breaks it all apart. And that's to do with how these groups are assimilated into looser different kinds of groups.
So again, I haven't thought about this much, but my initial reaction is yes, when the children rebel, that's salient, we hear about it, but the general story is that children follow in their parents' footsteps. It's just not very newsworthy. But that's my guess, and it would be very interesting to think about if there were differences between these groups. But my guess is that everybody is rebellious and they followed their parents in the end. Yes.
So I'm sorry if I missed this at the beginning. Which census year are you linking to?
1940.
So I understand that Steve Ruggles is working on linking multiple census years together, and I wonder if you were able to do that, if you would get a better idea of the ethnic origins of the people in this, so the death records, and if in that case you might be able to better measure whether or not the ethnic or cultural background really does make an impact. Because in this case, I don't know about the sample.
Well, so I'm using this distinctive last name as a shortcut to not link all the censuses. But if we had the censuses, we could look at these, quote, natives, and we could say, oh, this native has been here since 1880, the family, and it has been 1840, et cetera, et cetera. So one could do this and kind of disaggregate among the third generation of natives, and the third generation of ethnics as well. Among the first and second generation, we measure that directly. So we don't need more censuses to get the first and second generation. But this idea of, remember, all the children are above average, we're all non-native, and we're all native. All of the native population are immigrants. Yeah. So it's that kind of, one could disaggregate that if one knew more. And the last names are an indirect way to do that, but when this grandly linked march of censuses is done, which it will be soon, I hope, then one could do more. Maybe two more questions?
Just a question and clarification. One of the graphs later beyond this seemed to show that the second generation is less advantaged than the first.
Yes.
In general.
Yes, somewhat. Mm-hmm.
So I just wanted to get that clarification. So.
That one, yeah.
And those are statistically significant in some cases?
I mean, this is something I'm working on a little bit. So it's kind of this what is the true correlation here? Well, so there's measurement error in both of these. But the fact that the red dots tend to be inside the black dots is, I think, there's some information there. And this is what people have emphasized. I mean, the literature that was on things like food and things like that is saying, look, everybody's moving towards natives. But my message is looking at the same data and saying, let's think of it the other way around. The ordering is still like your parents. Yeah. I mean, it's a glass half full or half empty. I'm saying, well, most of the story is that people are like their parents, not that they're like natives. But both arguments have an element of truth. Maybe we should, one last question. Yeah.
I understand there's this sort of influence of immigrants, like the sort of immigrants that tend to come to the US or tend to immigrate to other countries. I wonder if it's possible to get records from the countries that these immigrants originated from, that life expectancy, socioeconomic status, to see how these immigrants compare to the average of the nations that they came from during that time, just to see whether or not these immigrants are representative of their country, and if so, then you can sort of parse apart the problem of like whether or not it's a culture, whether or not it's genetics even.
So yes, you can get the life expectancy at age 65 in, say, the year 1970 or 80 and compare it to this, and there is a correlation, but the reason I didn't present that is I think it's the wrong counterfactual. What we want to know is how long would people from that country live if they had been migrants to the U.S. at this time. So a good example is comparing the Russians and Russia, or Chinese and China. The world is totally different for the people who lived through the horrors of the 20s and 30s and 40s than the people who came to America and got to escape all those horrors. So the thought experiment is, and what's amazing actually is that for instance the Japanese life expectancy, the first generation Japanese live longer than the people who stayed in Japan, who have the longest life expectancy in the world. So there are a couple of things in favor of selection, and that's an approach taken by many papers. And one might be able to do something even further with like matching on last names. For the Norwegians, you could do it, right? We get the microdata and find out. Okay, let's stop here. Thank you, everyone.